So up to this point, we've looked at solving for reaction forces. We've taken objects like this. We have some supports, a pin, and a roller, and we put forces on it, and we ultimately figure out what are the forces of these reactions here. And that's all well and good. But today we're going to start to progress a little bit further, and we're going to look at the internal forces of the object. So, for example, if I had an object like a simple bridge, I have some forces on it. We want to start looking at the individual forces on the members. Now, when we say a member, we mean each individual piece. So, for example, this is a member, or that is a member, or that, or this. Any of these individual pieces are members. Now, on the bottom here, you look at this and you say, oh, that's one piece, but we have what's called a joint, an intersection of parts right here. So this is one member, and that is a different member. We want to start looking at the forces on these. Now, all of those forces are going to be one of two types of forces. They're either going to be tension, which means that the member is being pulled apart, or they're going to be compression, which means that the member is being pressed together. All right, so all of our members are going to be in either tension or compression. Now today we're not actually going to look at how to find the forces on them, but we're going to learn the first step, which is drawing a free body diagram for each joint. So let's start with a very simple shape. We'll just go with a basic triangle. We'll say that we have a force up here, let's say 200, and we'll have a pin and a roller. Now, this is what the problem would look like when we start, and you would have dimensions on here. And one of the first things you would do is you would remove the pin and roller, and you would replace them with reaction forces. So our pin would have a vertical and a horizontal force, and our roller would just have a vertical force. And of course, we would annotate each corner of this thing. We'd say we'd have A, B, and C. What we're going to do today is draw free body diagrams for A, B, and C. Now, I almost have to imagine that we take and cut out A, B, and C from their environments. So if I'm going to draw A, what I'm going to do first is I'm going to draw a point. This is point A. Now I'm going to draw all of the forces on it. So that is this arrow here. We want to label it. Remember, this is a pin, so this is a reaction force at A in the x direction. And then the pin also had a reaction force at A in the y direction. All right, so we have these two forces. Those are the forces from the outside that are acting on point A. Now, we also know that point A and point B are connected, and this member is either going to be in tension or compression. If it's in tension, imagine it's like a rubber band that's being stretched, it would pull point A this way. If it was in compression, it would push that way. We aren't going to know which one it is yet. So the normal thing you do is assume that it is in tension. We're going to assume everything's in tension. So since this member connects at an angle up and to the right, we're going to draw an angle up and to the right. And I'm just going to call this force of member A, B. So this is, for point A, the free body diagram for point A. Now, oh, we've got one right here. It's going to the right, force from A to C. All right, so that's for point A. Now, let's look at point B. So I'm looking at point B. I have this 200 force here. Since I know how much it is, I'm just going to call it 200. B and A are connected. Now up here we call this force AB. I want to be consistent, so I'm still going to call it force AB. I'm not going to call it force BA. I always want to write them in alphabetical order so I don't get them mixed up later. All right, now we assume this piece is in tension, which means if I had a rubber band going from A to B, it'd be pulling A up and to the right, but it pulls B down and to the left. So I want to call that force AB. And we also have member BC, and again we're going to assume it's in tension, so it's pulling this way, force BC. All right, so those are all the forces on point B. And now the forces on point C. So looking right here, this was our reaction force at C in the y direction, and that was from the roller. I have my force AC and my force BC. All right, now these are all of our free body diagrams for each joint. Let's go ahead and do this one more time. So in this one, we'll say that we've got a box like that. We'll say we have a pin here and a roller there, and let's say something's hanging off that corner there, pulling down. We'll say it's pulling down with 50. So I'm going to replace my supports with reaction forces. I'm going to label my corners. Oops. So label my corners A, B, C, D. This had a pin, so it's going to have reaction forces there and there. We're always going to say up and to the right because those are the positive directions. Later, if we find that it's a negative number, we'll know that we're wrong. And my roller was here. And remember, the roller looked like this. So we're drawing perpendicular to the surface. So since the surface was vertical, perpendicular is horizontal. So there's my reaction force at C. Now, when I go to draw the free body diagrams, I'm going to draw my free body diagram at A. I'll have reaction force at A in the x direction, reaction force at A in the y direction. Now I have member AB, so force AB. I have AC, this one right here, and I have AD. All right, let's go ahead and do point B. So the only things on point B is member force A, B, and B also connects to D, so force B, D. On C, we have a reaction force at C in the x direction. We have force CD. Notice I'm always drawing the arrows pulling away from the point, pulling away from the joint, showing its intention. Force AC here. Now D has a few more things going on. So I've got 50 pounds going down. I had force B, D going up. Force A, D going to the left. And force C, D going to the left. AD up and to the left, force CD straight to the left. And I like to double check when I get done, make sure I've got everything. So I kind of look around this point. I say, well, I've got 1 here, 2, 3, 4. Do I have all of them? 1, 2, 3, 4. Looks like I have all of them. All right, so this is our first step. Once we have solved for our reaction forces, our next step is to find free body diagrams for each individual joint. Now, once we've done that, let's go ahead and go back to a simple one again. Let's say this is our pin and roller. So we'll replace those with reaction forces. So when I go to draw these, A, reaction force A in the X direction, reaction force A in the Y direction, force AB. B has a 100-pound force here, force AB there, force AC there, and C has reaction force at C in the Y direction, force BC, and force AC. All right, same thing we've been doing. Now, here's where it gets a little bit more important. Ultimately, we're going to want to balance these forces. And remember our rules. We said the sum of forces in the X direction was 0, and the sum of forces in the Y direction was 0. How do we deal with a diagonal like this? It has both X and Y forces. The easiest way, so we don't have to start out using trig right away here, is to break this down. Remember, any force can be broken down into an X and a Y component. We're going to do that with any diagonal forces. So, our first step, we're going to draw free body diagrams. Then, we're going to redraw the free body diagrams with only X and Y directions. So, RAX doesn't change, RAY doesn't change, but force AB was a force up and to the right. We're going to replace that with a force that goes up and a force that goes right. Now, what are we going to call these? Well, it was force AB, so there's going to be force AB Y component and the force AB's X component. We're going to do the same thing with B. The 100 was entirely horizontal, so it's not going to change. We have force AB that needs broken down, so we're going to call that force ABY, and force ABX, and force AC needs broken down too, so force ACY and force ACX. Moving on to C. Reaction force at C in the Y direction is entirely vertical. It doesn't change. force AC is entirely horizontal. It doesn't change, but force BC does. So we have force BC in the Y and force BC in the X. So that's our next step to solving these kinds of problems. So our first step is finding those reaction forces, and the next step is finding a free body diagram for each joint, showing all the forces on that joint, both the forces that come from outside the shape, like reaction forces and applied forces, and also putting in the internal forces from the compression and tension of each of the individual members that's pushing on that joint. So we're going to draw in the outside forces and then all of the internal forces. Once we've done that, we take any of them that are diagonal, like this, and break it down into X and Y components and redraw free body diagrams.